Let's recap confidence intervals and hypothesis testing for proportions of two populations. So we've previously talked about and did examples for differences in population means. Whenever we didn't know the standard deviations of the two populations, we had situations where we assumed that the standard deviations were equal, we assumed they were unequal, and then we had the situation where we had populations that were dependent on each other. Okay? Now we're going to talk about population proportions. Okay? So we've got one population, and that population is divided into successes and failures. Let's just call them successes and failures, and we want to know what's the proportion of successes in that population. Okay? Then we've got another population made up of successes and failures, okay, only two categories, and we want to know what's the proportion of successes in population 2. And now we want to know, is the proportion of successes in population 1, how does it relate to the proportion of successes in population 2? Okay, so we've got a distribution for the differences in proportions, okay? Difference in sample proportions, I should say. So our sample proportion for population 1 is P1 hat. Our sample proportion for population 2 is P2 hat. We assume a normal distribution, and the mean of this normal distribution is P1 minus P2. Okay, that is the population difference. And the standard deviation of this thing is let's take a look at this. I'm excited. P1 hat times 1 minus P1 hat plus P2 hat times 1 minus P2 hat, okay? This is over N1, this is over N2, and we take the square root of that, okay? That is the standard deviation of the sampling distribution for the differences in P1 hat and P2 hat, okay? So this is the standard deviation we're going to use in our statistical inference calculations. Okay? And so what are those statistical inference calculations? We can do confidence intervals and hypothesis testing. Let's first talk about confidence intervals. We want a confidence interval, a set of bounds, within which we think this real population difference lies. Okay? What's the difference in population proportions? It's going to lie in here with some amount of confidence. 1 minus alpha times 100% confidence. Okay? And so how do we find that confidence interval? Okay? Much like before, we take a point estimate. What is our point estimate for that difference? P1 hat minus P2 hat. We add to it and subtract from it a margin of error. The margin of error is a function of what? Variability, sample size, and confidence. Okay? So we represent confidence with z of alpha over 2. And variability and sample size is represented with this standard deviation. P1 hat, 1 minus P1 hat over N1, plus P2 hat, 1 minus P2 hat, all over N2. Okay, so this is our confidence interval. Our 1 minus alpha times 100% confidence interval. We use a z distribution, as we always use a z distribution for proportions, because we assume we collect a large enough sample size that a z distribution is going to work. Okay. For hypothesis testing, variations on a theme, okay? Variations on the same theme that we've been talking about for quite some time now. We could want to know, for example, is P1 the proportion of successes in population 1? Is it equal to the proportion of successes in population 2? Alternatively, are they not equal to each other? Okay? We could rewrite this statement as P1 minus P2 equals to 0. That difference is 0. If those things are equal to each other, then their difference would be 0, naturally. Or we could write this alternative as P1 minus P2 not equal to 0. Okay? So this is what we end up inputting into our test statistic, but we could also address the other two kinds of hypotheses. Okay? We could talk about the situation where we have greater than or equal to in the null, less than in the alternative. Or we could have less than or equal to in the null, greater than in the alternative. Equality, always in the null, with all of these three possible sets of hypotheses, and the non-equality statement, the contradiction to equality, is in the alternative hypothesis. And so what would our test statistic here be? Our test statistic is a z statistic, and same setup as always. It's how different is the sample evidence. Okay, here's our sample evidence for the difference in proportions based on our sample. How different is the sample evidence from the hypothesized situation in standard deviation units? Okay, there's our standard deviation. P1 hat times 1 minus P1 hat over N1 plus P2 hat 1 minus P2 hat all over N2. And we take the square root of that. Okay, so how different is this thing from this thing in standard deviation units, where our standard deviation is from the standard deviation of the sampling distribution? Okay, so we've got confidence intervals, we've got a hypothesis test. Generally speaking, we've got a set of statistical inference tools to address differences in populations.